Welcome to Space Messenger. A new analysis of data collected on Venus more than 30 years ago suggests the planet may currently be volcanically active. A research group from Italy, led by David Sulcanese of the Università d'Annunzio in Pescara, Italy, used data from a radar mapping of Venus's surface taken in the early 1990s to search for volcanic lava flow, finding it in two regions. The discovery suggests that volcanic activity may be currently active and more widespread than previously thought, supporting previous indirect evidence that there is volcanic activity on Venus. This work is published in the journal Nature Astronomy. Venus is sometimes called Earth's twin sister. Though only slightly smaller than Earth, its CO2-dominated atmosphere has a massive greenhouse effect that bakes its surface at about 870 degrees. 465 degrees. Billions of years ago, Venus's surface and atmosphere were likely much like Earth today, with liquid water present. However, the ever-brightening sun and volcanic activity raised temperatures enough to evaporate all water from the planet, leading to a runaway greenhouse effect. Today, Venus seems desiccated, broiling hot, and seemingly dead, surrounded by dense clouds of sulfuric acid. Between 1990 and 1992, the Magellan spacecraft, launched from NASA's Space Shuttle in 1989, orbited Venus with an array of scientific instruments, dropping as low as 295 kilometers above the planet's surface. Comparing Magellan's first cycle of radar scans taken January-September 1992, Earth time, to the third cycle taken from September 1990 to May 1991, researchers performed a number of adjustments to make the comparisons useful, such as adjusting backscatter for different viewing angles. Both these cycles of scans had a left view angle from the satellite, whereas the second cycle had a right-looking approach. The first region encompasses lava flow features on the western flank of Sif Mons, a shield volcano at 22 sector north latitude on Venus. The second region was the western part of Niobe Planitia at a similar latitude, 20 further north, characterized by flat terrain, many shield volcanoes, and shield-related volcanic material. After investigating a host of other possibilities for their observations, the group writes that their best interpretation of the observations is that the surface scattering properties of Venus, such as its roughness and composition, changed from the first cycle of scans to the third cycle, an interval of roughly 16 months. The changed features observed are probably explained, they write, as new lava flows that took place during the Magellan mission. Lead author Sulcanese said, "Our study covered only about 16% of Venus's surface due to the limitation of comparing images from just the two left-look cycles. Therefore, it is likely that more evidence of this nature exists on Venus." The finding supports previous work that inferred recent volcanic activity on Venus from indirect evidence, such as variations in the sulfuric acid in the atmosphere, changes in a region's thermal emissivity data, and morphological analysis of volcanic-like surface features. It was found that Venus may undergo up to 42 volcanic eruptions a year, with an estimated 20 eruptions lasting more than 1,000 Earth days. This present work implies there may be as many as 120 discrete eruptions per Earth year. Estimates of the volcanic flow rates for each of the two regions were derived by assuming the thickness of the flows in the range of 3 meteors to 20 meteors, using the observed flow areas of the regions. Sif Mons has a maximum flow rate of 25 kiloyears Earth year, and Niobe Planitia 38 kiloyears Earth year. The sum of the maximum flow rates means volcanic activity on Venus could be the same order of magnitude as Earth's, making it more volcanically active than previously thought. Future missions like VERITAS and EnVision will revisit Venus's surface, said Sulcanese, allowing us to compare their data with the Magellan mission's images. This will enable us to identify surface changes over a period of more than 40 years. Don't forget to subscribe to our channel and like our video. Until the next video, keep looking up.